First worked example, to find the area of this segment, which is the overall aim of the question, it's broken it down into 4 different parts. And so to find the angle will be the first part, to find this angle here. And that will be found using the radius. I need to know a little bit more about this, and there's another part in the question here that says the 100 centimeters squared, and there's 100 centimeters, sorry, which is this total length. So that length there is 100 centimeters, which means that because I'm cutting this in half, this is a radius and it cuts at a perpendicular, I know that this is a half of that length. So this length here is 50. And therefore I have a triangle here with a 64 and a 50 in it, and then I can work out my theta using the SOHCAHTOA stuff. So for part A, I need to work out the theta, and that is using the hypotenuse and the opposite. So sine theta equals the opposite over the hypotenuse, and that means that the angle is the inverse sine or arc sine of 50 over 64. And on a calculator, I just need to make sure that I am in degree mode. 50 divided by 64, and that turns out to be 51.375 blah blah blah. It doesn't say in the question, oh, it does say in the question 2 decimal places, so then I'd have to write that as 53 point, oops, no, not 53, what am I doing there? 51.38 degrees. For part B, it's asking for the area of the triangle OAB, and that's just a half base times height. And the base is 100, the height is OC, but OC can be found using the Pythagoras theorem, and that is 64 squared minus 50 squared, square rooted. But then by throwing all that into a calculator, it's 50 times square root of 64 squared minus 50 squared. And it tells me the area of this is 1997.498, blah blah blah. And in the question it doesn't say 2 decimal places or anything, so I may want to leave that in exact form. Part C is now asking for the area of the sector of the circle, and the sector is OAPB, back to O again. And this is the angle, which is 2 theta, out of 360, times the total circle area, which is pi r squared. And the angle that I've worked out in part A is a half of the angle that I need, so I need to do 51.38 times 2, which is 102.76 divided by 360, and then multiply that then by pi r squared. So I'll leave that like this. And then on the calculator, divide by 360 times pi. I've found that to be 3673.088, blah blah blah. And that's the area of the sector. And in part D, it's asking for the area of the segment. So I need to do the area of the sector, and then I need to subtract the area of the triangle. And the sector I worked out in part C, which is 3 3.088, blah blah blah, and then I need to subtract the triangle, which I worked out in part B, which is 1997.498, blah blah blah. And then now by doing that on the calculator, I found this segment area to be 1675.59. I'll leave it like that actually. I'll do it to 2 decimal places. And the units here would be centimeters squared. In the second worked example, a wooden door wedge, and now I think about drawing this. So a wooden door wedge is like this, I guess, with a right angle here, in the shape of a sector. Oh, a sector of a circle, right? Okay, so then I know that this is going to be rounded on the outside here, and the radius of 10. And an angle of 24, and a constant thickness 3 centimeters. So the constant here will be that length. So it's 3 centimeters in that direction. To find the volume of the wood is the same as finding the area of one of the sector at the side here, and then multiplying that by 3. So the volume is equal to the sector area times 3. And the sector area is found by doing the angle out of 360 times pi r squared. And the radius is 10. Squared is 100 times 3. And on a calculator, 20 pi, which it doesn't say in the question anything about 3 significant figures or anything, but I would write that as 62.83 to 2 decimal places, for example, and that was in centimeters cubed. And in the final worked example, a cone and a sphere have the same radius. So again, I'd start to draw them. A cone and a sphere have the same radius of 12. Find the height of the cone if the cone and the sphere have the same volume. So I have a formula with shapes. I should write that algebraically. And the volume of the cone is a third of the base area times the height. Now I don't know what the height is, so I'll leave that as h. But I'll write that as hc for the cone, not the sphere. And that will equal the volume of the sphere, which is 4/3 pi r cubed. To find the height of the cone is simply to make hc the subject of the formula. And I can cancel my pi out here, and the third. And actually a 12 squared cancels with this 12 cubed to make 12. Overall I've cancelled quite a lot of stuff out here, but on this side I'm just left with hc, and on this side I'm left with 4 times 12, which is 48.